Hi everybody, on this week's Tips and Tricks I am going to be talking about math, and I may talk about math for the next several weeks. For those of you who actually know me, know that I was a math specialist for many years. I've even written my own books about how to teach math developmentally, so that's kind of what we're going to focus on. I get questions a lot from parents about how to help their children in math. I see comments in Facebook groups, either in dyslexia groups or whatever, about how, maybe which program to use, which app, and yeah, it makes a big difference on which app you're going to use or which program that you're going to use. But I want you to understand something very fundamental that you might not realize, so you might not be taking consideration. In the world of mathematics, there are 5 representations. That was actually published by some guy named Lesh, and it's called the Lesh model, but there's 5 representations. We have the real world context, so for doing 2 plus 3, we have, there were 2 girls in the classroom, 3 more girls came in, and how many girls are all together? That's the real world, that's the most concrete. We have a model where we could use things like color tiles to model that situation. So the 2 girls are represented by tiles instead of actual girls. We have a picture, so we could be drawing the 2 girls and then the 3 girls. Now some kids would draw it as the girls, and then that's more concrete, and then the more abstract drawing would be with just dots. Then we have the symbolic representation, which would be 2 plus 3 would equal 5. And here, especially if they group it together somehow, the 5 is just inside this grouping, whereas this is the symbolic representation. And this does not come natural to kids. They have to put meaning on those symbols. So the best way to teach children in general is going from a concrete to an abstract representation. So especially if they're in kindergarten, acting things out is going to be the best. If they're older, let's say in 2nd or 3rd grade, they might not have to act it out, but they can act it out, at least with their tools. They're going to still need tools. And in fact, if you gave me today a real-world problem that involved some kind of algebraic formulas, because I don't deal with that level of math anymore. I mean, I go about up to 8th grade, and that's everything else I haven't seen for 30 years. So, but I can understand it, but I'd have to build it out for myself. I might not have to act it out, but I at least have to draw in a picture for myself to be able to then connect it with numbers. And then I could figure out, oh, this would be the formula that this type of a problem is going to generate. But at first, the formulas or the symbolic representation isn't just going to pop out of my head. I have to build it out and figure out where are the numbers inside the picture. In fact, I always told my students, and when I was coaching, all the kids know, my most common question is, okay, where is the numbers in this picture? So if they have this picture, it's like, where's the 2, where's the 3, where's the 5? And it looks a little bit obvious to us, but when you get into bigger problems like double-digit multiplication, and they are building it, they lose the numbers really easy. And another thing is that we have right and left brain. The reason that these 5 representations work is because we have right and left brain thinkers. So our right brain thinkers are more gravitating to that building, the drawing. That's how they have to access the math. They need to be able to somehow act it out, either with the real world context, with the tiles, or with the picture, in order to make sense of the numbers. However, I had a lot of, let's say, gifted students who were dealing with the numbers very easy. Even me, growing up, math was very easy, but I was only dealing with numbers, and it wasn't until I took my math specialist courses when I realized, I don't really understand math like I thought I did. So, so those kids, they're only dealing with numbers. They will refuse to build it and act it out. That refusal just lets you know that they can't. So still making them, as we always told all our students, solve the problems in pictures, numbers, and words. Now they wouldn't solve every problem that way because it would take too much time, but initially, as they're really making those connections, they're solving the problems with pictures, numbers, and words. And one of the reasons is because when they do that, they're connecting the right brain thinking to the left brain thinking and making those really strong connections. So then my left brain gifted students became very powerful math thinkers once they were able to attach those right brain skills on it. So for today, I just wanted you to understand the whole notion of multiple representations. And if your child is struggling in math, I'm going to guess that probably they're a right brain thinker, because I found that most of the kids in my program that really struggled were just right brain thinkers trying to learn in a left brain way. And in order for them to access the math, they are going to need to be primarily or on the forefront building and drawing pictures, learning to draw a picture of what they built, and then learning to add numbers to show what they did with the picture.